This is module 8. Here we are trying to discuss in brief, in a most simplified manner, perhaps one of the most complex and complicated or challenging issues of natural language processing and computational linguistics. It is syntactic parsing, or to be precise, parsing. So, in this module, we will be trying to be as simplified as possible, because the process is so complex, so mixed up with so many issues of language that it is not easy to decipher, to understand the whole thing so easily. So we try to be very simplified, at least to have some preliminary ideas how the things are going on in this area of language processing when we are trying to understand the structure of a sentence and identify the roles of the various phrases, the syntactic functions of the words in formations of phrases, the subject-object relationships, the subcategories and roles, and many other information which is embedded in the sentence. So this module will try to discuss in most simplified manner how a natural language sentence can be parsed using the rules of context-free phrase structure grammars, and how the output may be used for all NLP tasks and many other domains of language application. One thing very clear to us: understanding properly each and every property of a language is a challenging task. It is a complex challenge. It's not so easy that you would understand all the properties, their functionalities, their entities that are used in language quite easily. We need a huge knowledge base of different kinds and employ those knowledge base in a sequential order or in a collective manner to understand the language. Language seems to appear very easy, but when you look into it in a very scientific manner, we find that it is a huge complex process. So when we have not achieved much success in understanding the, say, parts of speech word or word meaning, so if we claim that we can easily understand the sentence meaning, perhaps we are in the wrong side of the proposition. Perhaps we are more ambitious. So we have to be very much quite careful while we are dealing with the concepts of parsing. So parsing is actually to analyze a sentence following certain formalisms or grammatical rules to identify how the sentence is constructed and what are the information is embedded. So in this module, we'll first identify the ambiguity involved in the term, how in different disciplines it is that, and how the concept has undergone over the ages, the concept, its implication, the goal of a parsing, what is a parser, what kinds of parsing are basically done, how the output of a parser is generated, and how we utilize in different domains of human knowledge. So to give a simple definition, syntactic parsing or parsing in sense is the most common form of text annotation, but one of the most uncommon or challenge in the task of doing analysis, of language analysis. It's a kind of text annotation of written corpus after parts of speech tagging. So first is that parts of speech tagging, then next part of parts of speech tagging comes the parsing. It does some kind of syntactic analysis of sentences in texts according to certain grammar or a given language, and tries to identify the phrases and the clauses that are used as building blocks of a sentence. So its task is to identify those sentence clauses. So this syntactic analysis can be done both manually or automatically. The goal is to identify or to understand and explicate how the constituents are arranged in particular syntactic order to form sentences, and what kinds of rational interface or relational interface are there, and dependencies are there to those constituents that play the final realizations of the sentences. And that also gives many insights into the language, its structures, its components, its constructions, and others. So syntactic analysis can be done manually and automatically. Here for us, when traditionally we did syntax analysis manually, here we are trying to do it automatically. Ambiguity about the ambiguity of the term. Let us keep two things into mind, that there is a difference between a tagged corpus and a parsed corpus, both in the scope of its significance and analysis and relevance. What happens? Now, in the case of a tagged text, the tag list is meant to provide information about the individual words and their parts of speech, what kind of syntactic roles they play in the text. While in cases of parsed text, parsing provides information to identify the structural or syntactic relationships of the different groups of words like phrases, clauses that are used in the sentences. So we make a distinction between a parsed text and a post-tagged text. So tagged text has different structure, different goal. Parsed text has different structure, different goal. So in both cases, the sentences is all of tremendous importance. The term parse has different meanings in different areas. What we understood parse in traditional grammar is not that the same in computational linguistics or natural language processing, or not even same in cases of cognitive linguistics. So what happens in traditional grammar? It refers to the act of identifying subjects and predicates, phrases and clauses, main clause and subordinate clauses, and how these are interlinked to frame a sentence. It also involves the act of understanding the exact meaning of the sentences or several meanings embedded within a single sentence construction. So traditional grammar, in traditional syntax, we generally identify this task. In cases of computational linguistics or natural language processing, we make the whole process slightly different. Here, it refers to the scheme of formal analysis of sentences by computer based on a set of predefined syntactic rules modeled in the form of algorithm that is capable to analyze the sentence, identify the syntactic constructions, recognize the constituents, identify the relations between the constituents, and also the meaning of the sentences. In cases of cognitive linguistics, the parsing is no more about the traditional frame or the computational model. In this cognitive linguistics, it is the act of language comprehension and all its syntactic semantic nuances. Here we try to explore how people analyze sentences or phrases in terms of grammatical constructions or grammatical constituents to identify the parts of speech of words as well as the syntactic relations of larger constituents like phrases and clauses through the event of which comprehension of meaning becomes possible. So we find that in all three domains, both in traditional grammar as well as in natural language processing and in cognitive science, the term parsing is used mostly in a finer senses. So by traditional frame only identified the syntactic structures of the sentences. Computational linguistics followed some algorithms to parse the sentences, to analyze the sentences automatically, while cognitive linguistics want to understand the structure, to understand how people actually comprehend language or sentences and their meanings, and what kind of mechanism they actually deploy to understand those. So what we find that there is a migration of the traditional concept to mathematical concept. When traditional concept was mostly related with normal regular analysis by a set of rules and traditional knowledge base. Computational model actually tried to apply a mechanism of rule or an algorithm to analyze that. If you look at that, a sentence something like that, the man killed a snake that entered the room, in traditional syntax or traditional grammar, we know that here if we analyze the sentence, we get a subject, the noun, the man, object, the snake, predicate, killed a snake that entered the room, the main clause, the man killed a snake, subordinate clause, that entered the room, main verb is kill, and lexical verbs are killed, entered, others. But in the modern concept, that has to be understood in a modular form, in a highly symbolic representations, following the context-free phrase structure grammar. We can have a module. If you kindly refer to the tree table given in table 2 as well as the figure 2, you can really find out how the whole structure is built up. Here, S stands for S in a context-free phrase structure model. Here, S stands for NP plus VP or NP-VP, while the NP is made of a determiner, adjective, and noun. A determiner, adjective are not conditional components, are not permanent components, not obligatory, they are optional components. While the verb phrase VP stands for auxiliary verb, also NP, PP, and NP, while the prepositional phrase takes PP, prep, as well as an NP, and determiner is a class which contains some set of words or letters like A and D, that these are mostly words which are used as determiners. Adjectives has a full set of words, noun has a full set of words, auxiliary, verb, prepositions, and all this. So in cases of modern parsing, we find that it follows normally the context-free phrase structure model and use a set of syntactic rules to represent those in machine learning process. If we look at this figure 2 in a tree structure model, where we have shown how a sentence can be broken into NP and VP part, and how NP constitutes determiner and noun, how a VP actually has a verb and an NP, and again NP has a determiner and noun. So there is different ways of representing the things. Now the major issue, the major challenges, or the major goals, to be more precise, of parsing, why we need to do analysis of texts, parsing of texts. So there are 7 main purposes behind the process of applying parsing mechanism on a text. If we assemble together all those things and try to understand how it works, we can identify those roles. So first goal is identifications of words used in a sentence. So as a part of the parts of speech tagging, we also noted the identification of words is also important part and syntactic role, grammatical role. In the parsing also, we also need to identify the phrases, the words, how do they work. So single word can stand as a phrase, or the whole phrase can be formed by multiple words. So in cases of parsing, we need to identify those words that can constitute as a phrase or a phrase, assigning appropriate syntactic descriptions to words and phrases. Second important part of parsing is to assign appropriate identity of the phrases. If a sentence is made with, say, one NP, one VP, one PP, and several other MPs embedded into VP, then perhaps parsing will try to identify what are those MPs, what are those VPs, what are those PPs, what kind of syntactic relations they maintain among each other, if there is hierarchical relations among them, and how they are interlinked with each other. It also identifies grouping of multi-word units, collocations, phrases, and clauses. Also, it also tries to identify, to compile or group multiple phrases into one block. So when we say that sentence is made by NP and VP, what we do is that the VP part can have many other MPs or PPs embedded into it. So there is a question of grouping, that how this grouping can be done. So normally in a binary process, these are already done. Identifications of word group boundaries like phrases and clauses that are used in the sentence. Allocation of groups of two clause components, and different groups of phrases has to be assigned to different clause components. But if a sentence is written, it has to identify what is the main clause, what is the subordinate clause, what is the principal clause, and what are the main or subordinate clause, how those subordinate clauses are actually linked to the principal clause or main clause. Identification of main syntactic constituents. What kind of syntactic constituents are actually arranged in the sentence, in which order and how they are linked up, and naming those constituents accordingly. And identify also give them the names, different names, that these are that this is an NP, this is a VP, this is a PP, and others, and so actually develop a skeleton structure, how those components are combined, arranged, and placed together. So these are the 7 roles normally there. Also, it can take support from other areas to do these things. Normally, it follows the rules of government binding or context preference, more simple formalism, because the more complex formalism creates more complexities. But initial normal parser actually follows the context preference grammar. Then parser. What is a parser? Parser is an automatic tool which does these kinds of things in a sequential order, in a simplified order. So here, parser has several stages to perform. So parser is normally programmed to work out automatically or even sometimes semi-automatically, controlled by a parser generator, both in supervised and non-supervised manners. The input to a parser is often provided in the form of a text that is rendered into computer language, as a computer can hardly comprehend a natural language text produced in the existing forms. Then, in an advanced schemes that may be possible, but in an initial stage, it is perhaps not possible. So, the whole thing has to be presented in a machine-readable machine language. Parser actually works in different manners and sequences. So, we can identify some sequences, at least 4 or 5 different sequences it works. So, I will just look at those sequences, how it does. First thing, it needs to identify or detect the end of sentences. So, since the parser has to work on a sentence, it first identifies where a sentence ends. Means, when a random text is given, there should be specific sentence boundary marker, which is a very solid, valuable information for the parser, that this, from the beginning, this point to a particular point is a whole body of strings or string of characters actually constitute a full-fledged sentence. So, first it needs to identify the sentence boundary. So, normally, traditionally, even in our existing database, in the machine learning purposes also, we use the unique sentence terminal markers like full stop, like note of interrogation, like question mark. So, these are normally used as sentence terminal markers. So, in cases of machine learning part, we need to give sufficient information to the system so that it identifies the sentence boundary. Second stage is tokenization sentences. So, once the sentence boundary is identified, it needs to identify the tokenization part. So, split sentences into tokens. Having isolated a sentence, the parser will apply the NLP techniques to the text to split sentence into tokens, that is, words or word groups or punctuations. If possible, it needs to do that. But since parser also wants to identify the larger building blocks like phrases and clauses, perhaps ultimate eventual breaking into words or sentences into words may not be much useful, but sometimes it does tokenizations of sentences. Then it also needs to do a kind of parse speech tagging part. So, if it is a parse corpus, is fine, or it has to run the parts of speech tagging so that it can identify the parts of speech of each and every word used in sentence. So parts of speech tagging is a part of the parsing where it assigns the parts of speech words to the words used in sentence for better understanding and comprehension. Then it has another important part is it's called chunking. Chunking of larger units. The parser may take full support of a chunking tool to group those tokens of a sentence in larger units. Each chunk corresponding to a syntactic unit such as a noun phrase, verb phrase, prepositional phrase, adjectival phrase and others. So chunker is our chunking system is an appropriate tool for the parser which will break a sentence into larger chunks, identify the different phrases. The most crucial part of this is finding out the verbs in sentences. As you know that normally in a simple sentence we get one finite form of the verb and multiple non-finite forms of the verbs. But if it is a complex sentence or a compound sentence, we can have several finite forms of the verbs along with many non-finite forms of the verbs. So here the most complex task is to find out the finite form of the verbs. This is useful for many reasons. First, the verb is like the key to the whole clause. So it makes sense to get in touch with the main finite form of the verb. So once you identify the finite form of the verb, a major problem is solved because you know that when there is a finite form verb, then that must be either a full-fledged sentence, simple sentence, or maybe a clause which is embedded into a sentence. Also, sentence containing multiple clauses can easily be multiple finite form verbs. So finite form verbs has to be identified. In a language like English, we have specific set of affixes which are normally tagged with the verb in the finite form of the verb. That may help give us a clue, like s, ed, or ing, or en. These are the markers which always also help to certain time to identify. But the reality is that if you look at the corpus of sentences available in the text, you can find out that some verbs do not require any suffix. You can find out, say, leave, I must leave, or he should go. In those cases, there is no specific marker to identify that these are finite form of the verbs. So in that cases, we can give many examples that the verb finite form of the verb may not carry any specific marker. In that case, it's a real challenge for the parser to identify those appropriate finite form of the verbs. And all of the suffixes also appear in noun cases on various reasons. Also, we have noted that these which are also marked as finite form verb markers because of the allomorphic structures or allomorphic homographic forms of those allomorphs, we can find out many of them to be tagged with the nouns also. So S as verb tense or verb markers, finite form verb markers, is also used in English. It is also used as a plural marker. So machine has to understand, or the parser scheme has to understand, find out an example or a strategy so that it is able to identify the finite form verb markers. The basic task is to identify the finite form of the verb, because this will provide you sufficient enough information to understand that whether it is a full-fledged simple sentence, declarative sentence, or it is a main clause or subordinate or important clause of the verb. Identifications of non-finite clauses. This is another important part. There are finite clauses the parser has to identify. Also, the parser need to identify the non-finite clauses. So, non-finite clauses become non-finite clauses are always subordinate to the main clause. So, once these non-finite clauses are identified, the machine knows that these are important cues to understand the main structure of the main clause. So, it is very much necessary. Again, we can apply the rule of chunking and other mechanism to identify the non-finite verbs. Then finding the basic constituents. This is an important part to find out the sentence structure. Each step, it identifies the basic constituents and establishes their transitivity type. So as we know that once the basic constituents are identified, the main verb is identified, their subcategorization becomes important, whether it is transitive, whether it is intransitive or ditransitive. So these are the example references. Because of the transitivity, it can identify the number of clauses, main clauses, subordinate clauses, and arguments are present in the sentences. So these are the basics, a few steps that machine has to follow, the parser has to follow before the whole process of parsing is done. Then there are types of parsing. Broadly, we find two types of parsing. One is called full parsing, another is called skeleton parsing. So these both of them can be applied on the same corpus, but not simultaneously at the same time. The goals are also simplified. In cases of full parsing, what happens? It tries to provide as detailed as possible all set of information related to the phrases, related to the clauses, and to the sentence, or even to the words. So if you look at the figure number 3 here, I have given some examples of a simple text, how it is parsed at the sentence level following the full parsing scheme, and all things are described in full details, showing all the properties of the words as well as the phrases. On the other hand, if you look at the figure number 4, where there is a skeleton parsing, the basic tendency is to use a less freely finely distinguished set of syntactic constituent types and ignores the internal structure of certain constructions. So skeleton parsing broadly identifies the main clauses of the sentence and the main phrases of the sentences and the order of their arrangement in the scheme of parsing. So it is not that all the finer details are provided for each constituents. Normally, the identifications of clauses, identifications of phrases will suffice in skeleton parsing. After this analysis is done, parsing is done, the resultant output is normally known as tree bank. What we get here, if you look at the figure given in figure 5, an example of plain tree bank output of standards for parser, you can find out that whole thing is arranged in a tree structure, identifying all their properties or identifying the phrase structures or the clause structures in a well-defined manner, so that we can understand how the sentence is constituted, what are the main clauses or subordinate clauses, what are the NPs and VPs and PPs. If you look at the structure here, you can find out that if a sentence is kept, for example, the sentence like mutation increased resistance to drug but not drug 0 but not drug 1. If you look at the sentence, you can find out that in that sentence mutation stands as an MP identified properly, then increased the remaining part comes on the VP, then this VP also has NP for resistance as a PP to drug 1 but to PP and drug 2 not drug 2. So this is there 1 NP, 2 NPs and several other PPs and NPs within embedded into PP. So this structure also clearly shows that what we ultimately get is a tree bank where all the phrases are appropriately marked, identified their class and their relations in a hierarchical order. So this tree bank can be presented in a vertical way. If you look at this figure number 6 here, we have shown that tree bank is presented in a level brackets or in tree structure also. So because of the various ways of representations of tree banks in a language, but point is that in everywhere we can identify that structure at word level, phrase level, sometimes at the sentence level, and other functional agreement level are also marked out in those structures. At present, some tree banks are developed for German, in written German text, written English texts, and some of the tree banks are also available for Indian languages with reference to the ILMT project, where the basic goal is to develop the tree banks for almost in Indian languages. So since parsing is a very complex task, very complex challenging problem and very success in this area is mostly far-fetched. A lot of ask for tremendous collective enterprise effort to achieve even in limited success. Not much achievements has been made in even in advanced languages also. So we find only a few parsed tree structures available in English and other languages. And for Indian languages in the ILMT project, as I mentioned, some of the languages has some tree structures, while they are mostly in the form of a dependency parser, where the tree structures are available in the form of a tree bank. Now, finally, I emphasize on the utility of parsing on different domains of language technology and information technology, machine learning, computational linguistics, as well as in translation. Particularly, always we know that parser has tremendous information in machine learning. Here are the major domains which you can identify. In the area of information and document retrieval, the recognition and parsing of noun phrases is of special relevance for documents identification and retrieval of information from them. So, parsed corpus has a tremendous use in the area of information retrieval and document retrieval because of based on the noun structures or NP phrases or PP phrases, we can identify texts. In question answering systems also, there is need with a kind of deep parsing, because that helps us to understand the question raised and semantic interpretations of a sentence, and to decipher the appropriate information required for a particular question. So the input question has to be parsed properly, identify what kind of meaning it wants to retrieve from the question, as well as to generate appropriate replies. In terminology extractions, it is always necessary to have parsed corpus so that we can easily identify the noun phrases and identify the named entities. Particularly, the shallow parser can help us here because terminology extractions don't require the deep analysis of the syntactic analysis sentences. Lexical inductions is an important area where collocation, lexical association, multi-word units, as well as the argument structures of predicates are acquired from the parsed corpuses. Text summarization is another important area. Knowledge extraction, optical character recognition systems, speech recognition system, speech understanding system, bilingual text alignment is in natural language processing is a very valuable area where we need to align text structurally both into source text and the target text, not only at the sentence level, at the phrase level also. So if we want to align text at the phrase level, we need to have a parsed corpus where we can identify the phrases in the respective languages so that we can match them. Machine translation and speech translation are always the important areas where parsed corpora are maximally useful and maximally relevant for these purposes. So in conclusion, we can say that the parsing is one of the most challenging problems in natural language processing and in computational linguistics. It is a real challenge in the sense that it is not only asks for information from syntax or grammar, it also asks for information from morphology, from lexicology, from lexicon, from meaning, and other domains, and also need to combine those knowledge base together to develop a parser. So parser is a tool which does not only structural analysis of sentences, also provides certain amount of information related to meaning and information embedded into the sentences. So since parser is a very complex task, much success is not recorded in here, but we have understood that major works of NLP, major works of computational linguistics, major works of language applications can improve a lot, can solve many of our diverse linguistic requirements if we have good parsed corpora in Indian languages. But because of the complexities involved into it, not much success is recorded in Indian languages to have good tree bank or parsed. So for Indian languages, we are yet to develop good parser which can automatically parse sentences and generate tree banks. This is still an open and challenging area, and we can invite large number of young scholars who are interested in the area of computational linguistics and natural language processing to engage themselves to do more research so that they can develop good parser for Indian languages and good amount of tree banks for future works in language technology, natural language processing, and computational linguistics. Thank you.